Hello guys, welcome to this video. In this video, we're going to talk more about deep learning. So in deep learning, you can say that the target is that we want to mimic the process of human brain. So how does a human brain take certain decisions? For example, when you're walking, how does a human brain know whether to take the left foot forward or the right foot forward? One more example can be if you're on a road, you see some kind of animal. How do you classify that animal to be a dog or a cat? So you can say that you can identify that animal to be a dog by looking at its body, its features, its eyes, its nose, its tail, etc., its color, and same thing goes for a cat. So this decision-making process of a human brain, we want to mimic this process into machines. Deep learning is an integral part of artificial intelligence. So in this tutorial, we're going to talk more about deep learning, neural networks, who were the people who are the pioneers of neural networks and deep learning. We are going to talk about the history and why it was not famous before and why deep learning is being more famous now in these days. And after we have thoroughly understood the concept of neural networks and deep learning, then we'll be solving our own example. I have a data set, we'll be making our own notebook, and we'll solve a classification problem at the end. To understand about neural networks, we need to understand how did the concept of deep learning actually originate. So actually, if you think about deep learning, if you think about such things like self-driving cars and all that, you might think that it is a new concept. It started around 2000s, but that's not the case. Actually, neural networks were discovered around the 1940s, but at that time it was not famous due to many reasons. But actually, after 1980s, it caught on the trend because research in this area started gaining pace because people started to notice that neural networks are actually beneficial over other traditional methods. So as you see in the diagram, deep learning is one part of artificial intelligence. So the main aim of deep learning is that we want to mimic the human brain. We want to mimic the process of decision making in human brains. How does that occur naturally to humans? We want to mimic that process into computers. That sounds really interesting, right? But at that point of time, during the 1940s era, it was not gaining momentum. The reason to it is that it was not that good in predicting things. So the outcome was not really satisfying. That's why people did not pay attention to it. But the most important reasons to that is that technology was not really advanced at that point of time. But actually, if you talk about the technology now, if you want to train a neural network over a huge amount of data, it might take up to 2 hours, 3 hours, 4 hours, or whatever amount of time, depending on the data and the processing power of your own machine. So even today, it takes such a huge amount of time. So if you talk about technology at that point of time, it was not really advanced and it did not have that processing power. And if it had a huge processing power, it was really costly at that point of time. Now it is starting to get cheaper and cheaper. So of course, we need a lot of data and processing power to train the neural networks, and by using such huge amount of data we can be good in predicting things. So these are all connected. This is a picture of Mr. Frank Rosenblatt. He was the guy who invented a perceptron. So perceptron is nothing but a single unit of neural network. So it might look a bit complex right now, but actually it is really a simple thing. And he was an American psychologist, right? The deal with human brains and the functioning of human brains. So it was really interesting at that point of time. And I think this picture was taken around 1958 or something like that. Let us quickly talk about how did the storage evolve from that point of time up to the present time. So this is a picture taken during the year 1956. You can see that a 5 megabyte hard drive. So this is the 5 megabyte hard drive. You can see this is such a huge thing. It was being shipped by using an aircraft and it costed around $2,500 just to rent it, not even to buy it, just to rent it for a month. And afterwards, as technology evolved, from 1956 to 1980, this is an advertisement for a 10 megabyte of hard disk, and it costed around $3,400. This is, you can say, the size has significantly reduced now. And if you talk about storage right now, it is really cheap, of just for $16, and you can see it is just a single small chip which can fit on your tip of your finger. So you can see the size has significantly reduced as well as the cost has reduced due to the advancement of technology. According to this graph, from the year 1980 up to the year 2015, the hard drive cost per GB is reducing day by day. And I think we are going to reach zero at a point of time. But actually, if you have a Google account, we have kind of reached zero as well. Because if you have a Google account, you get 15 GB of free storage. Actually, I have even heard that research is being carried out if we can store data into our DNAs. So that will be really interesting if that happens someday. This is the Moore's law that talks about the advancement of technology from the year 1900 to the year 2045. So within the year 2015, we were actually able to surpass the brain power of a mouse. And now in the year 2045, it is predicted that we'll be able to surpass the brain power to equivalent to all the humans combined. This is a picture of Mr. Geoffrey Hinton. He is known as the godfather of deep learning. The reason to it is that because he was the person who carried out all the research around neural networks revolving around deep learning at that point of time. He's currently working at Google now. There are really some interesting and amazing videos of him teaching about deep learning and how does maths revolve around it. So I recommend you all to watch those videos. They are really the core concepts of deep learning. So our end target is that we want to achieve the process, or we want to mimic the process of the functioning of a human brain. And human brain is biological, right? So we need to learn the biology behind it as well. So let's talk about it in short. Human brain consists of neurons and neurological cells that are connected together. So there are not only one or two. So this is just a single neuron, and you can see in this picture that there are many neurons connected together. There are, I think, around 100 billion neurons in a human brain, and each one is connected to thousands of its neighbors. So this connection is important. The neuron does not work singly, they all work together in a harmony to do the magic. So a human brain can learn and adapt skills. So when we are small kids, our brain tries to adapt skills and we try to learn by seeing around. So when we see around, that is the data, right? So we are taking an input of some data around us, we are processing that data, and we're getting some output from it. So basically we are learning. So by learning, what I mean is we are training the neurons in our human brain. So that's how we are going to try and mimic this process. This is the first drawing of neurons provided by a scientist known as Santiago Ramon y Cajal. It was during the year 1899, and what he actually did was he dyed actual brain tissues under a microscope. He was basically drawing what he was able to see. So what we can see is that these are just the central part, and there are these huge long threads or rods that are connected to other neurons. So this is a single unit of neuron, this is a single unit of neuron, and you can see that these are all connected by using these threads or rod like structure. According to these drawings that Mr. Santiago has drawn, we see that the neuron that we have currently, the diagram, these really resemble the real figure. So this is the diagram that we have. This is the cell body of the neuron. Then there are these branches known as dendrites. Then this is the tail of the neuron known as axon. And actually these neurons cannot work. And actually I said neurons, right? I did not say neuron. A neuron cannot work on its own. It is actually pretty useless on its own. It can work in groups. So there are neurons that work together to do the magic. The analogy of this can be ants, right? An ant cannot do anything by its own. But if there is a group of ants, they all can pick up something and carry it together. So in the same way, there are multiple neurons that work together. There are billions and billions of neurons, and to a single neuron, there are thousands of neurons that are connected and they work together to do the magic. These dendrites are the receiver signals and axon are the transmitters. So actually what happens is that these dendrites are connected to axons of other neurons and so on. So this axon will be connected to a dendrite of other neuron, and this is the connection of all these neurons. So how are these connected? If you see, this is the axon of this particular neuron. So this particular neuron has this axon which is connected to the dendrite. So this is the dendrite of this neuron. And if you see, there is no physical connection. They are just connected by a gap known as synapse. So if you see in this particular diagram, these are the electric pulses. So this is the neuron body. This is the axon from where the signals are being transmitted to the dendrites. So these are the dendrites of this neuron. So basically axons are transmitting signals and dendrites are receiving these signals, and these dendrites and axons are connected by using this synapse. Enough about the biological part. Now let us talk about how are we actually going to mimic this process of neurons transmitting signal from one neuron to another neuron. So now this is, for example, a binary classification problem. You're going to have three inputs, for example x1, x2 and x3, and you expect some kind of binary output value. So this is known as the input layer and this is known as the output layer, and this circle represents a neuron. So these are three neurons and this is one neuron that is going to be having the output value, and in between we are having this hidden layer of neurons. So these four neurons consist of the hidden layer, and we are going to connect this neuron to this neuron. So basically we are connecting all of these neurons by using a synapse gap that we talked about earlier. So this input value is connected. For example, this is known as x1. It is connected to all these hidden layer neurons. Similar thing goes for input value 2 and input value 3. And in return, these have some kind of process in between the hidden layer. So this is just the hidden layer. They form some kind of output and they send this output to the output value, and this output value will give us the result whether this is 1 or 0. Basically this is just a simple binary classification problem. This is just a single unit, so you can call this a perceptron. And I know right now it might sound a bit superficial, because what does happen in this hidden layer, how are these things, or how are these input values processed over here, and what exactly is passed as the output value of the hidden layers to this output value. So we are going to talk about these things in detail. So you can see this animated image. So what is happening is, this is the input layer, this is the hidden layer, and this is the output layer. So binary, right? It can either be a cat or a dog. So we are passing in images of a cat, for example. Then we are passing these values from this input layer. So in this input layer, it can be anything. So for example, it can be ears, this can be color, this can be eyes, or these are just the features of that particular image. We're passing in these variables, or you can say data, as input, and over here we are doing some kind of manipulation, and we are passing it to the hidden layer. So after the hidden layer does its process, we're having something known as activation function. We are going to talk about that afterwards. So after we get any output from that activation function. So actually, about the activation function, this is the input that goes into the activation function. It is processed and we get some kind of output, and whatever output that we get is passed here, and according to the weights that are assigned to every particular input, we're going to get some kind of prediction based on whatever input values that we have. So suppose one of the examples can be years, right? So if the years are down or up, so if the years are up in this particular category and this will be the dominant feature, then it will be that, yeah, it is a cat if the ears are up, and if the ears are down, then it will be a dog. This is just an example. Don't really think about the ear thing, because some dogs have ears up. That was just an example so that you guys understand what I'm trying to say. So you can see this animated image. So what is happening is, this is the input layer, this is the hidden layer, and this is the output layer. So binary, right? It can either be a cat or a dog. So we are passing in images of a cat, for example. Then we are passing these values from this input layer. So in this input layer, it can be anything. So for example, it can be ears, this can be color, this can be eyes, or these are just the features of that particular image. We're passing in these variables, or you can say data, as input, and over here we are doing some kind of manipulation, and we are passing it to the hidden layer. So after the hidden layer does its process, we're having something known as activation function. We are going to talk about that afterwards. So after we get any output from that activation function. So actually, about the activation function, this is the input that goes into the activation function. It is processed and we get some kind of output, and whatever output that we get is passed here, and according to the weights that are assigned to every particular input, we're going to get some kind of prediction based on whatever input values that we have. So suppose one of the examples can be years, right? So if the years are down or up, so if the years are up in this particular category and this will be the dominant feature, then it will be that, yeah, it is a cat if the ears are up, and if the ears are down, then it will be a dog. This is just an example. Don't really think about the ear thing, because some dogs have ears up. That was just an example so that you guys understand what I'm trying to say.